I love the way that he was able to drop those golden nuggets, but also keep you laughing as well and engaged. So well done on that, Andrew. Thank you very much. Our next speaker is all the way from the United States, and I've also been told that it's his first time in Ireland. So guys, please be nice to him so that he'll come back. Kent Quirk is an inspirational leader with a cool head in a crisis, a well-known tech veteran of software engineering. He's been in the game about 40-odd years, building and growing high-functioning and flexible engineering teams. He also dons the hat of a software architect, has been an entrepreneur on multiple occasions, praised for his ability to solve complex problems that no one saw coming, a mentor and empowering a lot of engineers. I briefly got to know Kent as well, and I can honestly say I second all of the praise that's been donned on him. Just speaking to him, you can tell this is someone who really knows their stuff, and a total food nerd as well. I'm allowed to say that because I'm literally quoting him. I'm gonna stop waffling on. Do you get it? Waffling. I'm gonna stop waffling on. Please give a huge, warm ShipperCon welcome to Kent Quirk.
I caused a lot of trouble here by asking to run my own laptop, so forgive me for a second while we get this coordinated. And we're going to try this presentation display options. Oops, nope. Sorry. Stop mirroring. There we go. And then that one. And then 50 hertz. Okay. We're good. Almost there. And display slideshow on that. Oh, come on. Oh, full screen. That. Start slideshow. We got it. Hey, good start. Hello, everyone. I want to talk a little bit about this title, My Favorite Acts. I went to university in the northeast of America in New Hampshire. And the northern part of that region is kind of known for having taciturn, real kind of practical natives. And I was walking one day, and there was a guy chopping wood, and I said, geez, just watching him, he cut every one on the first swing. And I asked him about it, and he said, well, it helps to have a good axe. And I said, how do you define a good axe? He said, well, this one, for example, it's had 3 heads and 2 handles, and it's still going strong. So I want to talk about a tool I've been working on for a few years that's had kind of that level of change. If I can just figure out how to change the screen, I'll be good. For the last several years, I've been working at Honeycomb, and I've been working on this tool called Refinery. Refinery is a sampling proxy. So that means it lives in our customer's infrastructure, and its job is to receive all of their data, all of their telemetry, and then filter it. Its job is to reduce volumes so that the telemetry that reaches Honeycomb is both more meaningful and a lot less volume, because we charge for how much data you send us. So if you send less of it, it's going to be cheaper, right? So it does that intelligently. It's designed to be high performance. It's designed to be available. And one of the things it does is it passes on the sampling rate information. So it tells you, for example, it selected 1 out of every 4 of the traces that look like this. So it can be intelligently adapting to your traffic as your traffic changes. And it's also, because traffic can really vary depending on who you are, you may see spikes in traffic, you may see changes in the way things work. Stability is really important, and it needs to be able to handle very rapid changes in load. The typical, you see these things where the traffic is going to go up over the course of a day. No, it's not going to go up over the course of a day or an hour. Sometimes we see people will suddenly send us 1 million spans in a second. So Refinery's been around for several years, and I'm going to tell you that story today. This is me. I'm a staff engineer at Honeycomb, and they're over there if you want to talk to us later. So in 2019, the company produced something called SAM Proxy. I wasn't working here yet. The idea was we just wanted to do the basics of this thing, put together something that would solve this kind of problem of too much data arriving at Honeycomb. Now, one thing that's important about the telemetry that we were processing is we need to process entire traces. So it's relatively easy if you get one little piece of information, we call that a span, or an event, one little log, one little thing, and then you can make a decision right then and decide to drop it or forward it. But what Refinery is doing is saying, no, we're going to collect all of the traces about an operation. So your user hits enter, and a whole bunch of things happen across multiple services. And all of those things are all part of the trace, and they have a trace ID. And Refinery collects all the information about a trace at one time, and then can make an intelligent decision about it. So that puts a lot more pressure on memory and all that sort of stuff. So the first version was, let's see if this is possible. Let's try and do it. Do the simplest thing that could possibly work. It's still pretty complicated, but it was pretty basic. This illustration, by the way, was a photograph I took yesterday at the Irish Museum. This is an 800-year-old axe. So Honeycomb started to use it. We started to process internal telemetry from customers would send us stuff. We would write telemetry about that and send that to our, what we call our dog food cluster, because we eat our own dog food. And that dog fooding cluster was running dozens of instances at the time, running in parallel, and the system basically worked. Now, the stated goal of the problem is to improve the data quality. So the idea is you want to get rid of the irrelevant data and keep the interesting data. So what's interesting in this context? Well, errors are interesting. Failures are interesting. You know, Tolstoy's old line about every happy family is the same, but every, dysfunctional family is much more interesting. Same thing is true with data. Get rid of the stuff that's just working fine and is, nobody cares about. Keep the stuff that people do care about, and that's Refinery's job. So a couple of years later, it had gotten to the point where it's like it's ready for our customers to use. We had beta customers who were working on it and things, but basically at this point, we've done a bunch of things to make it more scalable, more intelligent, more configurable. A lot of the things that were hard-coded in the early thing are now in the configuration language. And in particular, one of the things that was introduced was rule-based sampling, being able to say, I want to keep all of the things that result in 500 errors in my cluster, HTTP status code 500, meaning something broke. Anything with an HTTP status of 400 means customer made a mistake, but you still will kind of want to see those. So maybe you keep 10% of those. And whereas you maybe only keep 1% of the 200 traffic. If it worked fine, just make sure you have a sense that it's still going on. Now, one of the things I started to mention, but forgot to finish, was Refinery decorates the data coming through it with the information on what the sample rate was that was used. So in other words, this trace represents 100 like it. So there's a factor of 100 attached to that trace. So then when you look at the data in Refinery, it pre-multiplies all that stuff for you and gives you accurate statistics about what your cluster is doing, even though only a fraction of that data has arrived at Honeycomb. So its job is to be, as I put here, this is one of the Honeycomb sort of tenets, fast and close to write. It's not designed to be your data store for permanent records and auditing. It's designed to give you actionable information live quickly. So Refinery takes that ethos and continues it. Its literal job is to get rid of a lot of information, but let's make sure that what we keep is useful. Now, along the change arc for this product, we've got a 1.0, but it's still pretty hard to run. So at this point, we're going from 1.2 to, cranking up through a bunch of versions up to 1.12 over the next year kind of thing. Security issues have to get dealt with. Things like don't put the keys on the command line so that anybody who can see your command line history sees your keys. Put them in environment variables, that kind of thing. A lot of trying to do best practices and support that sort of thing. Open telemetry. Around this time, Honeycomb has been, so open telemetry is a standard for telemetry, and Honeycomb has been a big motivator behind that, one of the companies that has been trying to support open telemetry. And although it was founded with our own libraries, just last week, actually, we archived a bunch of Honeycomb's telemetry libraries in favor of all the open telemetry ones that we've been supporting for years now. Better metrics for understanding what's going on, still not good enough. It's still kind of an inscrutable problem to try and figure out what's really happening with Refinery because it's a big, complex system. We also had this added a feature to fall back to dynamic sampling. So if you have your rules to say do all this stuff, and none of the rules applied, now what do? It used to be that we would just deterministically sample X% of that, and then we added a feature to add a dynamic sampler. Dynamic samplers can actually look at your traffic and go, we should keep more of this because it's happening less often and keep less of the things that are happening more often. And you can kind of tune that behavior. So lots of small bug fixes. We're focusing, the change here is trying to make the tool better. We're changing it, but we're changing it in ways that are kind of, we're hoping are trying to be acceptable to our customers. The reality was, though, that it's still a hard problem. It's still really hard to manage. Interesting little story here, cache management. So Honeycomb had this idea of, you collect a trace, you have to store it in a cache while you're waiting for it to finish. And you're hanging on to that, and now finally the whole trace is ready, and we can make a decision, and then we can get it out of the cache. The system wants to protect itself against memory overruns. So what happens when you start running out of cache space? What do? What Refinery was coded to do originally was, if it ran out of cache space, it would start ejecting things from the cache, but it would also shrink the cache. And the logic behind that was, well, we almost ran out of memory, so let's hold on to less things for a long time so that we can, because the cache was measured in traces. So you get one really big trace, and Refinery would go, wow, that big trace ran us out of memory, so I need to shrink the cache. And you suddenly find yourself with a cache that only holds 100 traces when you have 10,000 traces a second coming through. And it was a real mess. So that was just an early kind of semi-logical decision, but it made a lot of problem for our customers, because what would happen is they would have to then kill Refinery and restart it to get it to restart, to make its cache big again. And Refinery could be metastable. If you bring one node down, you'd have the system where now all the other ones have more load, and then they would start to go down. And then you could see a situation. I was trying to upgrade Refinery internally one time. I had 120 nodes running. That was around this time. 120 nodes running, shut down 4 of them to try to upgrade them, but then that caused 4 more to shut down, which caused another 8 to shut down. And then all of a sudden it cascades and the whole network's down. It was fine once you got it ready, once you got it stable, and then it worked really well. But then trying to scale it was a mess. So basically we just told customers, don't mess with it. Find the load that covers your needs and scale to that level, which meant you're running an awful lot of systems an awful lot of the time that aren't overloaded or not heavily loaded. So it was naive. It was also not getting a lot of love internally. The people who had started it weren't working on it much. And it was there, it was in use, it was valuable, but it wasn't getting the attention it needed. So now, we finally decided it was time to do something about this. And so the team I'm working on, which at the time was called the telemetry team, it's now called the pipeline team, we made it that team's real full-time job to concentrate on this thing. And I was the engineer who was kind of tasked with being the focus of that problem. So the first thing we did was just try to address some of the biggest pain. We introduced something called stress relief and stress level. So we added a new metric that was trying to calculate sort of how bad are the queue sizes, how bad is the memory use, and can we come up with a number between 0 and 1 which just says how healthy is this thing. And that actually turned out to be really useful and effective. And what we did was we established a system where when you get to a certain level of stress, Refinery would fall back to just trying to shed load. It would just start making deterministic decisions and just, just like I said at the beginning, instead of keeping whole traces and stashing them in memory, it would start going, you know what, 10%, buy. We're keeping some number, whatever the number was that you could set. We're just keeping that many, forwarding them on, and dropping everything else. And that allowed it to survive instant spikes. So we get these customers sometimes who will be like, oops, we had a system fail, or something happened, and suddenly we'll get 1 million spans on one trace in 1 second, and Refinery has to survive that. Because the restart time on Kubernetes is seconds or minutes, not, like many seconds or minutes, not milliseconds. So stress relief gave us that thing. We created a history cache so we could remember, even after we'd made a decision on a trace, some service comes along later and says, oh yeah, one more thing. In the old version of Refinery, we would hold on to that for a while and then make another decision about it, which would be probably randomly a different decision that was originally made. But now we remember that decision so that when new traces, new information comes in, it makes the same decision it made the first time. And so if it was going to show up in Honeycomb, it still shows up in Honeycomb. We also rewrote the rules engine to be faster because it was getting run a lot. But we still had this situation where one of our biggest customers was still running version 1.02, and now we're up to 121 because they had it working and they didn't want to mess with it. And it was very understandable, but it was hard on us because how do I release new features if my customers won't install them? Because don't forget, they're running this in their networks. This is not software as a service. This is something that somebody's running themselves. So we have to be able to convince them it's good. So our phase 3 is Pro Tool. We're trying to upgrade this thing. We're trying to operate as if our customer, as if it's a real tool, not just something we give away for free that maybe helps us make a sale. This is a real thing that real customers are running and really trying to depend on. So we looked at, we needed to make some changes. One of the biggest things was simple comprehension of how all of our configuration options and how they worked. We had one giant flat file with a bunch of names in it, and it was really hard to figure out what to do. Even our own internal people didn't know what to do with it. So we completely reorganized, restructured the config format as a big portion of our 2.0, and we called it 2.0 as a breaking change because you couldn't just take your old configuration and run it. You had to make some changes. So we had to do some work over, how are we going to change our configuration format? We also had some new samplers, a couple of which were donated by customers. And we wanted to try to make sure that we're talking to people more. And we still don't have anybody who's a product manager, but I got kind of like my team was acting as the product manager. So we were trying to make some statements about what we should do, and we were backed by the organization around it. It was a very stressful time. We were basically saying to people, trust us, we're making breaking changes, and our sales team had to kind of buy into that. Our support teams had to buy into that. So one of the things we did is we made a tool to help people make the conversion, to make the step from version 1 to version 2. And we'll translate your old configuration files. We'll also translate your Helm charts from the old one to the new one. So if you were kind of working with us, we gave you the ability to make these changes automatically and step up with it. A lot of time was spent making that tool. In the end, it's probably only a dozen people who actually ran it, but it was still worth it because it was a statement from us that we care about your experience, we care about what you're doing. It showed we took their pain seriously. I just noticed. So as part of this, we had some performance improvements, and one of the things that was nice was we made it better able to run in parallel. So we switched our internal cluster. At this point, it was up to 140 nodes internally. And we switched it from 140 relatively small nodes. They were 4 CPUs. And we switched it to 35 16 CPU nodes, but we were only consuming 10 of them so that we could bin pack other processes on those same nodes. And that was actually a fairly major cost savings in our internal networks. And our customers, we encouraged our customers to do a similar thing. So now we're starting to get a little more professional. These early releases after 2.0 were a lot of quality of life and bug fixes, as we heard from people. Oh, I wanted to do this, but I couldn't. This didn't work. So we added some new rules features because people were saying, I'm having trouble expressing the rules that I want to express. So we added more capabilities to make Refinery more intelligent. We added support for OTel logs because people are sending their traces, but they're also sending logs, and they're identifying the logs as part of these traces, but Refinery was ignoring them. And now we have the ability to integrate those logs with the traces and filter them the same way. But the important thing here was, after we did this 2 or 3 times, and we're doing monthly releases, and we switched to, instead of just the change log of here's the links to all of the GitHub PRs that we committed here, we started writing narrative text about what it is we're doing, why we're doing it, establishing a roadmap, and explaining to people what's the process here that's going on, and our customers started to trust us. We had a chart. Unfortunately, we don't keep a lot of back data, so I couldn't show this to you, but we had a chart of what versions were customers on and how many people were on the latest version. And the number of people on the latest version was like 10% when we started this process. And then it got to the point where I think it was 2.4 or 2.5. I released it on a Friday. Yes, Friday releases are possible. Released it on a Friday, and I came back on Monday and looked, and over the weekend, I'd had, I think it was 6 customers adopted over the weekend. Now, these are enterprises. These are big, big customers. And yet they immediately jumped on the changes because we kind of developed some of that trust. And that was exciting for me. And now, generally, we see that almost everybody adopts the latest version relatively quickly, within days or weeks. So I'm very happy about that. So now we're getting into phase 4. What do we do now? We finally have a tool that we can kind of trust, that our customers can kind of trust, that's doing the job that it says it does on the tin. So we sat down and said, what's the next goal for us? The next goal was dynamic sampling. That seemed to be what everybody was demanding. I want to be able to run enough refineries at my predicted peak so that they can handle that load. But overnight, when my customers aren't very busy, I'd like to throttle back. So I went from, some customers are like 2 to 1. Our internal network is maybe 3 to 1 from morning to night. But we have customers that go, one customer they see something like 10x on the hour, once an hour for 8 hours a day. And everything else is like, so once an hour they run this big thing and they throw massive quantities of data. They don't want to be running 10 times as many refineries all the time. They want to be able to dynamically scale that. So we wanted to support dynamic scaling with Refinery. It's a hard problem, actually, because it needs to be able to cope, as I said before, it needs to be able to cope with those spike loads. If that spike comes in, it has to not crash while you're waiting for Kubernetes nodes to spin up. So there's a lot of little work right there. So we started to rethink the way we established our network of peers, how refineries know about each other. We changed that from storing data on Redis, just treating it like a database, to using a pub-sub model where people would announce themselves and get published. And in fact, the pub-sub model was pretty successful, so we started using it for other things. So now the cluster as a whole can reflect its stress to all the other members of the cluster. So instead of one node going into stress mode because one trace is breaking it, we can scale the whole cluster up and down together. We had this insight that, so I just implied something there I should actually cover. So imagine, your system is sending traces, and the traces have an identifier. It's basically a large random number. And all of the spans in a trace have the same identifier. So now we have to make a trace decision. And you say, OK, well, does any span in this trace have an error? We'd like to keep that thing. Well, how do you know that? The only way to know that is to concentrate the information about the trace onto one node. So the way Refinery does that is it uses trace locality. So it takes the random number trace ID, and it uses it to select a node, and that's the decider node. And now every span that comes in from that trace, no matter which refinery it hits originally, gets concentrated on that one node. This works great until you get the mega trace. You have 1 million spans come in, and they all go on one node, and every refinery in the system is throwing data at that one node. And that's where the stress relief thing comes in. So stress relief says, whoops, OK, I can't deal with this, and starts shoveling it off. But you still have one node has the spike, whereas all the rest are happy. Now, with pub-sub, we can say the whole cluster is unhappy, so the whole cluster can together make this decision. So that was what we called distributed trace locality. We made it so that instead of one node getting all the data, all the nodes get all the data, or all the nodes get part of the data, and then they share information just about the key fields that they need to make the decision. It seemed like a great idea. It seemed like a cool decision. We got all excited about it, put it in the roadmap. We built 2.7, 2.8, 2.9, adding all the features. Added all the pub-sub stuff. We added some new rules features. We added this redistribution mode where when you shut nodes down, the traces, they unload themselves. All this is great. And then 2.9, we go, distributed trace locality. We're finally ready for it. We've got all the pieces. It's the culmination of this roadmap. And we put it in beta because we just weren't real sure about it yet, because our own traffic, it seemed to be working, but we were having trouble with it at big scale. And then we ended up releasing 2.91, 2.92, 2.93, 2.94, trying to fix it. And it just didn't work. It failed. We wanted this feature pretty bad. And it turns out, I went and did some detailed simulations. The problem becomes linear. The scaling problem is linear, but the trace locality communications is exponential. And so you end up with this thing where when your network is big enough, you actually cost more memory, cost more comms than you save. And that can break down your network. So small customers could deal with this, and it was OK. Our small clusters, all our early testing on our internal clusters, no problem. The big problem came with spikes of traffic on big customers with big clusters. And it just doesn't work. So good news is it was still in beta. The feature defaulted to off. And we are now actually going to turn it off and remove the code in the next release, because this feature didn't meet the needs of the market. And that's a change. Like, we had a plan, and we executed the plan, and it was a bad plan. So now we're saying, all right, another way of skinning this cat is to actually make it use less resources. The problem is the cost of running Refinery at scale. Maybe we don't need to be quite so robust about dynamic scaling. Maybe what we need is to just do it better. And we threw an amazing engineer at this problem. He's somebody who can take Go code and turn it into something that maybe doesn't quite resemble Go code anymore, but it's way, way faster. So it's more efficient in its use of memory. It's really impressive, the work he's done, with support of a whole team. It wasn't just one person, but it's one brain architecting this. And so the result has been that we've actually, if you multiply out the amount of memory we use and the number of CPUs we're using internally, just Tuesday, we cut that number in half after this thing had been running for 2 weeks in our internal clusters. So we've had a major, major performance win on this, and I'm very excited about it. And we're not done. 3.1, we've removed a CPU bottleneck because there was still this one place in the system, the individual internal collect loop, that was single-threaded and couldn't be multiplexed. So it limits the size of the servers you can run Refinery on. And that's getting removed in 3.1. So it should be better able to scale across a variety of CPU architectures as soon as we get that out. We've also done a bit with the metrics to clean up and improve the metrics, because a number of the metrics now no longer apply because of the work we've done to remove. Some of our queues are gone, some of our caches are gone. So that's why we're calling it a 3.0, because again, people are going to have to change their configurations. But that tool I wrote for 2.0 still applies to 3.0, so you'll be able to run the tool and clean up your data. So it still cuts wood, but it's a very different looking tool than it used to be. The performance work we did, it added a lot of complexity to the tool. The code is no longer quite as easy as it used to be to work on, and boy, I would hate to throw a AI at it because it doesn't look like any of the other Go code that's out there anymore. It still has some of these issues that Refinery's always had. Its job is to drop data. And sometimes we get customers who are like, but I never want it to drop anything I don't specifically want it to drop. And it's a nice desire, but it's kind of conflicting with some of the other desires about this tool needs to be resilient more than anything else. And so achieving that desire of never doing something that wasn't in your brain when you configured it is actually, if you want that, you also need to accept that it's not going to be scalable and it's going to be a lot more expensive to run. And the people who want that often don't want the other thing. Like that's the conflict we get. It's like, okay, but it's still, I don't want to run as many of them. So we're still fast and close to right. That's the thing that we're trying to do, that we're really trying to focus on. So, you know, our model here has always been improve the quality of data. That's what I said, you know, right at the beginning. That was the focus on this. We're trying to give people tools to improve the quality of the data that reaches Honeycomb. And to date, that improving the quality of data has been about focusing on the deletion of data that's irrelevant or less relevant. Now we're moving toward the next steps in the roadmap will be additional decoration of that data while it exists. So you should be able to do, you know, instead of sampling at the trace level, you can say, you know what, I don't need all of the details of, say, my database spans. I just need a summary of them. Refinery will start to be able to do that. We'll be able to do some other kinds of aggregation. How many errors were on this trace without having to count them individually, we can promote that information. This will enable some things that you couldn't do before in Honeycomb and couldn't do before with this data. And it's going to be a key part. We're building a telemetry product that's related to this, and Refinery is kind of part of that. And the telemetry product is, our pipelines product is about enhancing your data pipeline. So there's still an evolution. It's still moving forward. We're still doing these changes. And I think, you know, my takeaway is change is hard. the change is hard for us, but the change is hard for our customers too. And we need to make it so that the customers can change along with you. The customers have to come along, and you have to make it attractive to them. You have to make it worth it to them. And the way you do that is by telling people what to expect, what's coming, why they should care. But also, maybe don't overpromise. One of my regrets on this whole thing was telling people we were going to be successful at making Refinery fully dynamically scalable. And that didn't work. And we had to revise the roadmap, and we had to go back to people and say, yeah, maybe turn that feature off. It's not working. So I think you want to be able to watch what's going on. You need to monitor what's happening so you know when you're in trouble. You need to be listening to customers, talking to customers. The roadmap is a really important tool. It helps you to both express your intent, but also to revise your intent as it changes, and to help keep people up to date with what's really going on. So all of these tools together, it's about communication, it's about relationships, and it's having this arc, having the story to tell is the thing that customers really care about, and that it reflects into you. The way you run your organization is reflected out. So I think that's about it. Thank you very much.
I could honestly